All right, so here is a lesson on proofs continued. So we're just gonna run through some more examples of some proofs that you guys are gonna get on your test and on quizzes and such. So, all right, so it says work with your partner. We're just gonna do this individually. So go ahead and pause the video. This should be a review from the last lesson. All right, so always first step, we write what's given. Then it's saying AB plus BC is equal to the whole length, which is AC. So this is the segment, because it's a segment addition postulate. Okay, then it says AB plus AB is equal to AB plus BC. So we need to figure out, okay, what did these people do? All right, so it looks like they said, okay, this is equal to AB plus AB. And then the AC is also equal to this. So since AC is equal to both of these, we can set them equal. So that's the transitive property. Okay. Then it looks like, okay, we have the same thing on either side of the equal sign, so I can subtract AB and subtract AB on both sides. These cancel, so this is from the subtraction property of equality. Okay, all right, so we're gonna keep going. I would say, hey, work with your partner on this one, but since this is online, just pause the video, try it on your own, and then we're gonna check yourself again. Okay, so given is always whatever the given is. All right, then we know based on what it says, EBA is angle 1 plus angle 2. Okay, angle 2 and 3 added together, which is by the angle addition postulate. AB. We substituted angle 1 in for angle 3 here. Okay. Then 2 and 3 is equal to angle EBA. We gotta switch them around by the commutative property, my bad. So commutative property of addition just basically means I can switch 1 and 2. And now we're looking at angle 1 and angle 2 are equal to CBD. All right. Because those two have to be in that order to read that angle like that. And then the transitive property, we know if this is equal to angle 1 and angle 2, and this is equal to angle 1 and angle 2, then these two have to be equal to each other. So the measure of angle EBA is equal to the measurement of angle CBD. All right. Pretty easy stuff. All right, so let's head on over to this proof. Same thing, we're just gonna keep working through them. So this is another example. So since we have 2 given spots and we have 2 givens, I'm just gonna write 1 in the first slot. And I'm gonna short, instead of writing midpoint, I'm just gonna put NP. Okay, and then C is the NP of BD. So how do we know, based on that information, we were given B is the middle of A and C. So we know AB is equal to BC. We know that by the definition of midpoint. Okay, and so that's what you'll usually see, okay? If it's giving you some key information like it's the midpoint, probably the next one's gonna be the definition of it. We're gonna be defining what that definition means, what midpoint, why is the midpoint significant? Same thing here, C is the midpoint of B and D, so we know BC is equal to CD. Okay, and if BC is equal to CD and BC is equal to AB, we know we can cancel these out and AB is equal to CD. So that's called the transitive property. All right. Great, so this one's extra practice. Go ahead and try this one by yourself. Okay. Again, we always write the given. We know BM is congruent to CM. Okay. Then we are told that CM is congruent to DM. And we know that because LK, it says LK and line K and line L bisect each other. So we'd say that's also given or definition of bisect. Okay. Then we know BM is congruent to DM because they're both equal to CM. So that's a transitive property. Okay. I don't know if I'm forgotten an I over here. All right, then whenever you see these lines in the congruent symbol and then you don't see any lines and no congruent symbol, that's always definition of congruence, and vice versa. Because definition of congruence is saying that if these are equal, then that means they're congruent, and vice versa. If they're congruent, that means they're equal. So you have to, in order to go back and forth between those, you have to do that. This one's talking about measurements. This is just talking about the lengths of them are equal. So you just have to specify that when we're talking about, we're going from the lengths of them to being congruent to now the measurements of them are congruent. All right, but anyway, so the segment addition postulate says that BM plus AB, right, equals AM plus BM. Okay, and now by this last step, how are we able to change this BM to DM? Okay, substitution. And that's it for that one. We're just gonna keep going through some examples. 2 more. All right, and then I'm gonna put up some practice problems for y'all. Okay, to work through. But okay, so it says AEB is a complement of BEC. So that means that these two angles together equal 90 degrees. So in the picture form, right, I might as well go ahead and put right angle, okay? So that would tell me that the measure of angle AEB plus the measure of angle BEC is equal to 90, okay? Then it's telling me, okay, AEC is equal to AB or AEB plus BEC. So I got that from my angle addition postulate. And why is it angle addition and not segment addition? It's because we're dealing with angles. Okay, so then over here we know, okay, how do we know AEC is 90 degrees? Is the definition of complementary, right? Because we knew these two, or no, this is substitution, I'm sorry, right? That's how we got to that conclusion. We know this whole thing is equal to 90 and this whole thing is equal to that, so we can conclude that. So sorry, this is transitive or substitution. Forget that, sorry about that. Okay, then we'll keep going. We know AED and AEC is equal to 180, and we know that by definition of supplementary angles. I could also put linear pair, beneficial linear pair. But here we go. So the substitution property of equality tells me that I can substitute AEC with 90. Okay, then we can subtract these 90 degrees from 180, and by the subtraction property of equality, we know AED is equal to 90 degrees. Got that? So we'd subtract 90 on both sides, and that's how we'd get the last step. All right, so go ahead and try this last one. Pause the video and try it. All right, the first one should have been easy. This is always given. All right, and since we know RT is the midpoint, so our M is the midpoint of RT, we know RM is equal to MT. Okay, and by this segment addition postulate, we know that RM, let me see where we're trying to go. Yeah, RM plus MT equals RT. All right, and so, let me see if that's what they want. So RM plus equals RT. Then it says RS plus SM is equal to MT. Oh, okay, sorry. Wrong one. I knew I was messing up. All right, so we want to try to define what RM is. So RS plus SM is equal to RM. Okay, now see that works, segment addition postulate works for that whole distance or the smaller one. But it would have been smart to use this one because it's in our next step. Okay, so we need to figure out, okay, how did they get from here to here, right? They just substituted MT for RM. So that's substitution. Property. All right, and then we just switch them around, so that is the symmetric property. There we go. All right, and that is it. Sorry about a couple mess ups over there, but hopefully you'll see that that's kind of how you have to work through these proofs. You have to see, okay, does that make sense in context of what I'm looking for, and work through that. But hopefully I'll see y'all soon. Y'all have a wonderful day. God bless. Bye.